Hello, I am Mr. Rogers, and you are watching the video notes for section 1-1 in your textbook here on chemical interactions. We're actually going back, and this first section of the book is all about changes, so chemical and physical changes. And in the previous sections, we've been talking about the periodic table of elements and how we place them in the periodic table of elements. And now we're going to start talking about what happens when we combine different elements, and this is where we get our cool demonstrations coming forward also. First thing, guys, something new I want to try is this is something you do not have to write down, but these are the lesson objectives. So when we're done taking notes at the end, these are things that we should end up knowing or having learned throughout the lesson. So you should be able to define and compare element, compounds, mixtures, atoms, and molecules. You should be able to compare chemical and physical changes. You should be able to explain how bonds are changed during chemical reactions and identify evidence of chemical reactions have taken place. Those are the big things we want to get from our notes today. So, first thing here are physical changes. What's a physical change? And I know most of you have a working background on physical changes, but a physical change is a change in the shape, size, or state of matter. And so you can see down there below it says typically can be identified using the 5 senses. So these are things you can see happen. These are things you can smell. Things you can hear are going to be your best way to kind of describe how this happens. So what happens is it's still the same substance. We haven't changed what it is made out of. If I tear a piece of paper up into a million pieces of paper, it's still paper. Chemically, it's still the same. If I melt ice, it's still H2O. I just changed the state that it was in. So it's still ice. Grinding down or chopping up a piece of wood, turning it into just sawdust, it's still wood. Chemically, it's still the same. We just changed the size of it. It's a big thing there. So anytime we change that shape, size, or state of matter. On the other side of that, we have chemical changes. And so chemical changes now actually change the composition of the substance. So it's now chemically different. So what are some signs that a chemical change has taken place? What can we look for during the reaction to know that something's happened? Gas is produced. Anytime you burn a piece of wood, you can see the smoke. That gas is being released as it burns. The temperature changes. Sometimes there's heat released, like in a fire. Sometimes heat is absorbed, so it actually gets colder. Sometimes a solid is formed. We'll talk more about this. It's called a precipitate. And remember, if you're not part of the solution, you're part of the precipitate. So, a permanent color change, that means the color is changed permanently, you can't change it back. One substance kind of seems to disappear. We would say it doesn't really disappear, it seems to disappear. And we have the odor change, there's a different smell to it. And these are all ways that we can kind of gauge if a chemical change has taken place. So again, it's chemically different. The bonds have broken, rearranged, now we have new substances after that chemical change has taken place. So again, common examples are if you burn something, burning wood. Oxidizing would be like when rust is formed, that's a way of oxidizing. You chemically digest food. You break that food down, you rearrange it so your body can take in the nutrients. And reactions with acids. So acids tend to break down and chemically rearrange the molecules in the substance that it's reacting with. And we'll see that here along the way as we go further in the unit. So there's a big idea between chemical and physical changes. Now, on this next page, guys, so when these chemical changes happen, we're combining atoms, or rearranged. And so a compound, with the vocab terms here, these are all kind of in bold and italicized, is when 2 or more elements chemically combined. Alright, so again, a compound is when 2 or more elements chemically combined and you form that bond. So H2O combines together. Now, a molecule then is like the smallest part of a compound and is the 2 or more atoms bonded together. And that's really where we get into that specific ratio of elements. So H2O, we have 2 hydrogens, 1 oxygen atom, so it's a ratio between the different elements, how many of one element combined with how many of the other element to form that molecule. So they're always in specific ratios, H2, so 2 hydrogens, 1 oxygen. So now, on the other hand though, we have things called mixtures. And mixtures goes along more with a physical change. We're putting things kind of in the same place, but they're not chemically combining. Trail mix, great example of a mixture. You're putting things in the same place. You eat a handful, you get some of the sweet, you get some of the salty, but each one of those foods, the chocolate or the salty pretzels, have their own flavor to themselves. So they keep their own properties. Now, a solution is just another type of mixture. We say it's a well-mixed mixture. It's kind of the best possible mixture where the parts are evenly distributed for the most part. An example is salt water is a common example. When you drink salt water, first of all, but you still taste the salt. It's still water. Each one is still in there. We can still extract one or the other. If we boiled water, we have the salt left behind, so we can still separate the salt and water from each other in one way or another and still have just salt and just water. So that's a solution, still a physical change, but they're in the same place. Now, when these chemical changes actually happen, remember we have these bonds that are holding atoms together. And a chemical bond is that force that holds atoms together. A lot of times this is done by those valence electrons we'll talk more about in the future, but a chemical bond is that force that holds two atoms together. And then finally here, when these chemical reactions occur when chemical bonds break or when new bonds are formed. So during a chemical reaction, bonds often break and are reformed, new ones, and we get new molecules are being formed out of that because they're being rearranged, they're being reshuffled. And again, we look for those signs of the chemical reaction we talked about before, looking for those signs of the color change, we're looking for the gas production for a precipitate. Those are our signs that a chemical reaction has taken place. Alright guys, so these are the notes for today. And again, to kind of recap, we'll jump back up here to our lesson objectives. So we defined and compared elements, compounds, mixtures, atoms, and molecules, what they mean separately. We compared chemical and physical changes. We explained how bonds are changed during the reaction. And we identified evidence of chemical reactions. Again, the color change, odor, those type of things are what we're looking for. So I thank you guys for watching. Have a good day, and we'll see you along the way.